All right, well, say good morning, everybody. My name's Rob Macedo, KD1CY. I'm the Amateur Radio Emergency Services Skywarn Coordinator for NWS Boston, Norton, Massachusetts. And we have KB1KQW, Jim Palmer. He is the Skywarn Coordinator and assistant for the North Shore of Massachusetts area. He also has a lot of experience with both web and video production, so he's kind of our producer and has helped me in the past to teach these Skywarn sessions. We have taught Skywarn sessions online at the National Weather Service in Norton, Mass. We taught 3 sessions back in May of this year. Obviously, because of COVID, we have not done any live classes. However, we worked with our office to come up with a path to allow amateur operators and non-amateur radio operators interested in becoming Skywarn spotters to join the program. And what we've done is we've done the presentation online, and then there's a 20-question quiz, and that quiz is what allows you to become a Skywarn spotter. Some offices have done the training and just not bothered with a quiz or giving a spotter ID. We have elected not to go with that approach at our office. We like to have folks take the training, enjoy the training, and then if they're interested in being a spotter, they take the quiz. When they pass the quiz, they will get their spotter ID. So we've adopted that approach because we want to keep a level of rigor and maintenance into the program. And given COVID, this is the best option. In the past, we have allowed, we've had folks take the live class first for their first time actually becoming a spotter, and then they take a refresher. They can take the refresher either at a live class or online with retraining every 5 years. Because of COVID, what we've done is just expanded the online program and toughened up the quiz a little bit to make sure people have retained enough of the material to become a spotter. Again, this is a Boston Norton office policy. Some of the other offices in New England may vary, and so for those that are outside of area, we can definitely work with you and the surrounding offices to allow for more information and how to become a spotter at their office. They may, for example, allow you to take the quiz here, and if it's passing, they may give you an ID, or they may give you an ID just based on the session. It will just depend on the different office policies and how they've handled it here in this COVID environment. So that's the first thing I wanted to kind of address as kind of a kickoff. And I'm sure there'll be some other questions in between Jim and I. We can answer them across the training and then post-training as well. We're very happy to be able to kick off the New England Aries Academy with this session. It was planned to be part of the live session at the NE Exposition. We have done this session at the Boxborough New England Division Convention, now NE Exposition. For the last several years, it's always been well attended. So very happy to be able to kick off the Aries Academy with today's presentation. So with that, we'll get into the program a little bit, and hopefully this is showing up well on computer screens, the animation here. This is showing the new, or maybe not so new now, because it's about 3 years old, the GO-16 satellite imagery. And you can kind of see how the imagery captured the eclipse going across the country. And what you can also see is this system here, which would eventually become Hurricane Harvey, kind of kick off the 2017 Atlantic hurricane season. You'll also see another hurricane out in the eastern Pacific here. The GO-16 satellite imagery updates every minute. To give you an idea, the fastest Doppler radar scan is 5 minutes. So it gives you an idea of the difference in these technologies, and the satellite imagery is definitely farther along with this technology than the Doppler radars are. And the radars will eventually be improved to do just as much detail and scanning at a faster rate over time. But it gives you an idea of some new tools are now becoming more operational and typical tools that are being used during severe weather, tropical systems, winter weather, and so forth. So this is just to kind of kick off and give some people idea about the technology that's available. So what is the National Weather Service? So It's kind of weather behind the scenes. You see, there's a lot of TV, radio, internet, cell phones, newspapers, for that matter, all the social media that's out there. There are several entities that put out some really good weather information on the social media side of things. The Weather Service is 122 weather forecast offices issuing local forecasts and warnings. And then there's a number of the National Centers for Environmental Prediction that help with the models, climate and seasonal outlooks, storm and tornado prediction, hurricane tracks, and so forth. Some of the national centers, for example, are National Hurricane Center that issues the tropical storm and hurricane watches and warnings for the coastline. The Storm Prediction Center, which issues severe thunderstorm and tornado watches that usually cover multiple states. And we'll talk a little bit about the differences in severe weather watches and warnings as part of this presentation a little bit later on. What is the National Weather Service? It's a federal government agency sponsored by the U.S. Department of Commerce. It's sponsored by NOAA, the National Oceanic Atmospheric Administration. Of course, it can stand for a couple of other things. It could stand for the National Organization for the Advancement of Acronyms, and it can also stand for no organization at all. And just so you know, there is some humor injected into the presentation, and some of this humor is from the forecasters themselves, and that's one of them. So I wanted to provide a little levity while we go through important topics in the training. The prime directive is protection of life and property, timely weather and river forecasts, and there's nationwide coverage with 122 local forecast offices and 11 national prediction centers. And we've talked a little bit about the national prediction centers already. You can see the coverage of the NWS Boston Norton is all of Massachusetts except for Berkshire County, all of Rhode Island, and Hartford, Tolland, and Windham counties of Connecticut. You can see the New York City or Brookhaven, New York office covers much of southeast New York and a part of northeast New Jersey through southern Connecticut. And the Albany office covers through Berkshire County, Massachusetts, and Litchfield County, Connecticut. So as you can see in Connecticut, they actually deal with 3 different Weather Service offices. Southern New Hampshire, which had been a part of the Norton office, Cheshire and Hillsborough counties, became part of the Gray, Maine office at the request of the New Hampshire Office of Emergency Management, which wanted to just deal with one Weather Service office for their state. Other than that, the coverage areas are based on the radar coverage into the respective areas, and that's why these are divided as they are. And you can see on the top map here, some Weather Service offices cover parts of states, some cover parts of multiple states. And again, a lot of it is based on the radar coverage for that given office. So it just gives you an idea of the breakdowns of the different Weather Service offices. There's 26 meteorologists, forecasters, technicians, and others staffed 24/7 and 365 days a year, including weekends and holidays. They give observations, forecasts out to 7 days, and all the watches and warnings. Now, I'll speak a little bit from a COVID standpoint. There are still folks that are staffed that come into the office, but it's very bare staffing there right now. A lot of the management comes in only on certain days. From a National Weather Service amateur radio operation perspective, we do have an amateur radio station at the Weather Service, but unfortunately with COVID, we have not been in the office since COVID started. And to be honest, most of the staff is operating remotely, not all, but they keep a very, very minimal staff in the office, even from the paid meteorologist perspective. So I won't say that we won't operate from there in the COVID environment, but it would take a very extreme weather situation for that to occur, which has made it a little interesting for some of the larger severe weather events that we've dealt with this summer to handle all the data and get it all to them in a timely fashion. But we've, I think, done a reasonable job of getting the most critical information to them and following up with the more data and more information post-storm. But making sure they have the critical things that are needed from a warning standpoint. And it's actually meant that we've had to have more folks get involved with running nets on various repeaters, depending on the coverage. I will run things from wherever I'm at or from my house, but the coverage into some of the farther northern and western parts of our area is a little tougher given where my geographic location in the South Coast, whereas the Weather Service office, while not exactly centrally located in the coverage area, is a bit further north and west, which provides some better coverage into for example, places like central and northern Massachusetts and out to northeast Connecticut. So, and these are some of the things that we've been working on and dealing with in this COVID environment from an amateur radio operations standpoint. So why are you here? You know, we need eyes on the ground because 1/3 of warning decisions are based on reports. You know, to give you an example, on June 23rd, 2015, we had 2 tornadoes that day. One was very well documented and known in near real time with damage in Wrentham, Massachusetts. Well, there was a second tornado here near Mount Wachusett that was not really understood and known to be causing damage. There was no tornado warning issued, and the next morning, this video was sent to the office, and a survey team confirmed an EF0 tornado near Mount Wachusett. That's how critical spotter reports can be. And this is a severe weather situation, but it could be in other situations, winter weather, tropical weather. It can give the forecasters a bit more idea of what's happening on the ground, despite all of the technology that's out there. You know, even despite, you know, many weather stations being online and such, having the ground truth, the eyes on the ground, in tandem with this technology is where you get a real complete picture of what is happening on the ground and how significant a severe weather event may be. So Skywarn is you, the civilian volunteer trained by the National Weather Service to report specific weather conditions to the Weather Service: wind gusts, hail size, rainfall, and cloud formations. It can be average citizens, amateur radio operators, and the common bond is interest in weather and helping public safety. Now, this video here would be showing an example of a bad weather spotter. It's probably not going to come through on a webinar very well, so I'm just going to forego the video. But if I were to view it on here, you would see how the person thinks they're driving through a tornado where there's no evidence of that. They were in very heavy rain that could cause flooding. There were definitely strong winds that, if they got stronger, could have knocked down trees where he was spotting, but he was saying it was a tornado where it wasn't. And what we're trying to do here is get people to report what they see versus what they want to or think they're seeing, and just report exactly what is happening at their location, and when it meets that criteria for reporting, that they report it in. So that's what the video would describe if we were in a live class setting. These are the reported tornadoes from 1950 to 2019. I'll just make a comment that in 2020, we did have 2 tornadoes in Massachusetts. It was out here in Southeast Berkshire into Western Hampton County, in a relatively rural area. In fact, I would argue that in Western Hampton County, if it were not for the efforts of amateur radio operators who were able to get reports both in from public safety and actually have a couple of amateurs go into the area to look at some damage in Tallinn, Massachusetts, we might not have confirmed a tornado there because it was just so rural. There were plenty of trees down. It was an EF0 tornado, but it was in a very rural area. And there were a couple of streets affected that required assistance from Public Works and Public Safety. But if it wasn't for getting those initial reports and having a couple of amateurs in the area, it easily could have been undocumented. And if it hadn't crossed those streets, it may have just happened in the woods and we would not have known about it. So it gives you an idea of how some of these localized events can be in such rural areas and cause issues. So you can see here the number of tornadoes out in the western and northern areas here are much higher. And then as you go southeast, you see the numbers drop off. And the reason for that is a lot of times we need to have turning in the atmosphere. Helicity is a measure of turning in the atmosphere, and that usually means a south or southeast wind at the surface versus west and northwest winds aloft. And that's what gets the turning in the atmosphere going. Well, particularly in the early spring into the early summer months, it gets the influence of the cooler marine waters, and that cooling effect actually does not allow for the severe thunderstorms to survive as well as it gets in the eastern part of the region. But as you get later in the summer and into the fall, when the temperatures are warmer, that marine influence is less. And sometimes other factors in the atmosphere can counter that stabilizing effect of the marine layer. So you can see the numbers are drop off, but they are not zero. So they can happen in the eastern parts of New England, but they are reduced a bit because of that marine influence. So out here, you see 43 in Worcester County. If you kind of added these counties up here, you would get a number of around, I believe it's 51, thinking on the fly here. So you see that the numbers here are pretty much the same when you combine the counties together. It would be roughly the size of Worcester County. So these numbers are pretty steady here out in the west, and then you see them drop off to the east because of that marine influence. So that's why those numbers are different. And next year we'll update these numbers for 2020. There are actually 5 tornadoes, I believe, in Connecticut this year, although all of them were not in our coverage area. And a couple were associated with Tropical Storm Isaias, which was a significant widespread damaging wind event. And I'll also comment, we had a severe weather outbreak on Wednesday, October 7th in eastern New York and southern New England that is being reviewed as to whether it was just what we call a mesoscale convective system, or a very powerful line of severe thunderstorms, or if it was even a little bit stronger than that and called what we call a derecho, which is Spanish for big wind, and there are certain requirements. It has to last for at least about 400 miles, and there's a bit of an assessment that needs to be done for that. So we've posted some photos of the damage on our Facebook page for WX1BOX, our amateur radio station at NWS Norton. We're going to be adding more to that, and we're continuing to document that event with pictures, videos, reports, because it will determine whether or not it will classify as a maybe it wasn't a derecho like what they had out in Iowa and such, but it may meet the minimum requirements for what we'd say would be a weak derecho, but at minimum it was a strong mesoscale convective system, a vigorous squall line of storms that swept through the area on Wednesday with close to 250,000 without power in Massachusetts alone, and similar numbers in eastern New York and outages in Connecticut and Rhode Island. So it was a very significant severe weather event. To give you an idea, the amount of power outages from that event rivaled Tropical Storm Isaias in Massachusetts. So just some information there to be aware of. So wanted to spend a minute or two just to talk about that on this slide. Again, these are the damage reports from the Norton coverage area from last year. The numbers for this year have been tabulated on a preliminary basis, and next year's training will feature that updated information. You can see last year we had 5 tornadoes total in our coverage area. The 3 in Massachusetts were all on one day on July 23rd on Cape Cod, which effectively doubled their number of tornadoes recorded since 1950. So a fairly unusual day on the Cape that prompted those 3 tornadoes, and then you see the other 2 that were one in Rhode Island and 1 in Connecticut. And then you see the wind damage and hail reports. These are just a number of reports that either the first report that confirmed a warning, or the first report where no warning was issued. There we get literally hundreds of more wind and hail reports of 1 inch or diameter or more, and also a lot of reports of hail under 1 inch that is reportable but not considered the severe criteria that aren't covered in this table. So just wanted to give a little more detail behind these report numbers. These are the different preparedness websites. Weather.gov/Boston is the National Weather Service Boston page. If you go, there are very similar links for the surrounding New England Weather Service offices that you can pull up if you're outside of our coverage area. There's the Storm Prediction Center. They are the folks that issue the severe thunderstorm and tornado watches. These cover multiple states. A watch means those conditions are possible. They may not occur, but they are possible. But when there is a severe thunderstorm or tornado warning, that means the conditions are imminent or will be occurring very soon. And those warnings are issued by the local forecast offices. Ready.gov is a great preparedness site, and you see the different emergency management websites for Massachusetts, Rhode Island, and Connecticut. Certainly there are those for New Hampshire, Vermont, and Maine, thinking again that this is a New England-wide audience here. There are preparedness social media sites, the National Weather Service on Facebook and Twitter. There's at NWS Boston, the U.S. National Weather Service Boston page on Facebook. They put out preparedness infographics. We will often share them on our social media, which is on WX1BOX, which is our amateur radio call sign at the National Weather Service in Norton. And we will share amateur radio and non-amateur radio Skywarn spotter information of damage and such on our social media pages, and the Weather Service will share those pages out to on their social media as well. So it works in tandem. And if you think about amateur radio is the original form of social media, and we are still a form of social media today with our nets and how we create awareness on situations and our natural distribution of folks across the area. It is a very natural relationship to help from a Skywarn perspective. So we are also on these forms of social media. We work in tandem with the Weather Service to share information and interact with people. And what it also allows us to do is interact with Skywarn spotters that aren't amateur radio operators. And some of them will get their amateur radio licenses based on their experience working in Skywarn. So there's that relationship there that's, I think, very critical for the service. And it's a good way to practice our communication skills, and then when communications go down, we have that much more capability to provide support and some relationships in place with other agencies through our work in weather spotting and the National Weather Service. We do post, we have coordination messages, pre-events that we post. We'll be posting one later today on some strong winds expected in southeast New England and the possibility for some severe thunderstorms again later today and this evening. And up in northern New England, that threat is a bit higher. So there could be some more issues with severe thunderstorms. I don't know if it will be like Wednesday. I think it'll be a bit less, especially in southern New England, but always something that we have to watch for. And then with some of the larger events, we will post post-storm reports and information on those events. And we did that for the severe weather outbreak on Wednesday, and we'll be updating that information as well later today. So this is some of the examples of preparedness from a social media standpoint. There's also NOAA Weather Radio. That is still a great way to get weather information. Comes directly from the Weather Service. A lot of the alert radios will alert you when severe weather is imminent or occurring in your area. You see the different NOAA Weather Radio transmitters in southern New England. There are similar transmitters up in northern New England. And this is still a great way to get weather information, especially the alert systems if we were to get any kind of nocturnal severe weather, which is rare but does happen here in New England. We did have some nocturnal severe weather back in 2018 and 2016 in southern New England. So this is a great way to gather information in those times, especially at night when folks are sleeping. And then I'm sure everybody has had at one point or another this wireless emergency alert go off. That is used for tornado warnings and certain flash flood warnings for a given area. Also, there's technology being developed for, not all severe thunderstorms are created equal. If you look at some of the severe thunderstorms we had on Wednesday, that might have been a case to use the wireless emergency alert because the winds were so strong, although short-lived, they were so strong that it probably warranted sending out one of those wireless emergency alerts to alert people that this isn't just a maybe a marginally severe storm with a brief wind gust to around 60 miles an hour. These were storms that had wind gusts well over 60 and sometimes over 70 to near 80 miles an hour, which is more of a more significant threat. So they're developing technology for those higher end severe thunderstorm warnings to put out those alerts. There's many radar applications and other weather applications, especially for iOS and Android, probably less for BlackBerry these days, but these are very helpful. And these wireless emergency alerts can also be very helpful. Again, we won't show the video here, but this is an example in August 23rd of 2016, August 22nd, 2016, where we had severe weather at 3:15 a.m., a tornado touchdown in Concord, Massachusetts. And that was an example of how the wireless emergency alert, when the tornado warning was out, alerted people on their phones. People took cover. There were no fatalities or injuries from this tornado, credited to the timely warning and the wireless emergency alert getting the information out. And amateur radio operators provided much of the key preliminary information so that an NWS survey was done several hours later to determine that there was a tornado, an EF1 tornado in Concord, Massachusetts. So thunderstorm ingredients, you need a number of ingredients for thunderstorms to develop. You need a good amount of moisture. You need a source of lift, which is typically a cold front. Sometimes it could be a warm front, and there's some other subtle sources of lift that can get the thunderstorm process going. This is kind of the triggering mechanism for these storms. And then there's the need for a level of instability. So usually when you have cooler air aloft with warm air at the surface, that's when you can get the thunderstorm process going. And that was another key thing in the Wednesday severe weather outbreak. We had very cold temperatures aloft. Even though high temperatures were only in the 70s and dew points were like in the 50s, not super humid or moist, that temperature difference between the upper levels of the atmosphere and the surface were quite high, and that allowed for a more unstable environment. And the other key thing not listed here, and we talk a little bit about later, is strong winds aloft or wind shear aloft, and we had that on Wednesday as well. So when you combined all those ingredients together, that's what provided a robust severe weather event on Wednesday, October 7th of this year. So again, moisture, that's what forms the clouds and precipitation associated with thunderstorms. Primary sources are the Atlantic or Pacific Ocean, the Gulf of Mexico, and to a limited extent, the Great Lakes. Instability, again, the cooler it is aloft, or that temperature difference between the surface and aloft is what gets you greater instability. When it's warm aloft and cool at the surface, you don't have instability, or if it's warm across the whole column. You know, there's days where we get temperatures in the 90s and we say, well, we might have thunderstorms today. Well, if it's warm across that whole column, you will not get that activity. So you need to have some cooling aloft and a temperature difference between the surface and aloft to get that instability going. And the greater the instability, the more favorable conditions are for thunderstorms. So if we look at today's event, there's a question about the level of instability, but we have very strong winds and a strong triggering mechanism coming in. So is that going to be enough, or will we have enough of the other ingredients to compensate for the lower instability? Those are the questions that the forecasters will be reviewing and looking at the possibility of severe weather for today. Source of lift is a forcing mechanism to cause air to rise, setting the thunderstorm process in motion. Typically, it's a cold front, but it can also sometimes be a warm front. Other sources of lift can include differences in solar heating. Dry lines, more common in the plains than here in New England, but that's another example. Differences in terrain, and then certainly sea breeze fronts, which we get plenty of being near the ocean. That can be a source of lift and triggering mechanism that can get the thunderstorm process going. The different thunderstorm stages, you have the cumulus stage. A lot of times, right, we never get beyond that. We get the cumulus clouds. We don't have the other ingredients. It doesn't go any farther than that. But then when we combine with the ingredients to get thunderstorms going that we talked about, that's what gets us into the mature stage of development of storms, which you see in here in this picture. And then eventually the thunderstorms will dissipate, and you can see how in this picture here, they're losing their organization. And how long they're able to stay strong or possibly severe and in that mature stage depends on how the ingredients for the day line up. So thunderstorm types, you have the single cell, otherwise known as the pulse type of severe storm, which has an occasional severe threat. The multicell clusters and multicell lines of storms. So if we look at what we had on Wednesday, it was a vigorous squall line or multicell line of storms. There's certainly a greater risk for severe weather with those conditions. And then the supercells, which are isolated and discrete cells, they are have the best risk of producing tornadoes and are a significant severe weather threat. The single cell or pulse storms, they usually last about a half hour, and they're occasionally severe. More often than not, they're going to produce small hail, gusty winds. Small hail may just get to the severe thresholds. And we don't talk about what the severe criteria is till the second part of the training. But this hail can get to marginal severe thresholds, gusty winds that might just touch up into the severe category, and minor flooding issues can occur from these single cell storms. This is an example here. We don't advise folks to take video while driving unless they're using a permanent dash cam. This is an example of a single cell storm. It's kind of straight up and down. You can kind of see the full context of the storm here from a distance. And again, might hit severe thresholds, but generally speaking, will hold just below severe thresholds. And this is one of our most common severe weather modes of activity in southern New England. And then as well as the multicell clusters and lines. And they can last, in the case of multicell clusters, they can last 1 to several hours, and they may become severe. We're going to talk quite a bit about this shelf cloud feature along the leading edge of storms. They're very important to note because they can produce strong and damaging winds under the shelf, but they are often confused with wall clouds, which are more indicative of tornadic development. And we will go through those differences at length here in the next few slides. Multicell clusters produce hail and certainly have the chance to produce larger hail. Strong winds, a greater risk for that, as well as flooding, because with a multicell cluster, you could have several cells working in tandem, giving heavier rain for a longer period of time over a given area. That's what these multicell clusters can produce. So this is an example from August 2013 in East Longmeadow, Mass. And you can see the radar. There were a number of multicell clusters of storms that day, particularly out in the Pioneer Valley, Western Mass area. They had hail up to golf ball size in East Longmeadow, and many reports of hail between nickel and $half size. In West Springfield area, there's also some down trees and power lines from the damaging winds. That gives you an idea of what multicell clusters are capable of. And then there's multicell lines that can last hours or even days, and they are often severe. And this is one of the most common types of severe weather for southern New England, like what we saw on Wednesday, October 7th, 2020. Again, we have the greater risk for hail, damaging winds, and flooding. This is an example of a squall line from June 9th, 2011. We were actually in the Storm Prediction Center issues convective outlooks with categories for severe weather. We were actually in a moderate risk for severe weather that day. This would have been one of our biggest severe weather events. However, this was 8 days after the Massachusetts tornado outbreak, where we had the 38-mile-long track of the tornado, high-end EF3 tornado that affected western Massachusetts. So this event was a bit overshadowed from that. And there was actually severe weather earlier that day on June 9th with significant wind damage noted in parts of Rhode Island and some big hail out in western Mass. And it was a very active 2011 was a very active severe weather season across the country, and New England was no exception that year. But this squall line extended from southern Maine all the way down through the mid-Atlantic states. Squall lines are a line of severe thunderstorms that form along or ahead of a frontal boundary, along or ahead of a cold front typically. Linear in structure and can be more than 100 miles long, and they're often preceded by a shelf cloud extending horizon to horizon. You see this photo here from Wolfgang, who is an amateur radio operator involved with Needham, Massachusetts emergency management. This was actually what we call a low-topped squall line. You know, some people think you have to have storms that are up to 50,000 feet in height to produce severe weather. That's not necessarily the case. It depends on the day. Even the storms we had on Wednesday were what we call lower topped severe storms, maybe about 20, 25, 30,000 feet. And it just depends on the weather conditions of the day, how big and tall the storms have to get to produce severe weather. The squall lines and the winds out ahead of the squall line, under the shelf cloud is where the strong winds are. Sometimes it's referred to as an outflow boundary or a gust front. As you see here, you get the winds and then you get the rain. And sometimes you may have some winds associated with that rain, and then the storms move through. That's what squall lines do. That's very indicative of what we had on this past Wednesday, October 7th, 2020. Here's an example. Put the shelf cloud in motion. This marks the leading edge of the gust front and is usually produced by rain-cooled air. It slopes down and away from the precipitation area. So you see here in motion, and as you get under the shelf, that's when the strong winds occur. They could be producing, down trees at that point, and then you get into the heavy rain and potentially hail associated with the squall line. You can see a shelf cloud is a multi-shaped cloud. It's attached to the storm base, sloping away from the rain. And you can see on the radar here, the radar can detect these at times. And the farther away they get from the storms, the less strength on the winds. But even out here in Northeast Connecticut, there were some winds around 30, 40 miles an hour from this feature. And again, it's like an outflow boundary, a gust front, and the shelf cloud under the shelf is where the strong winds are. The strongest winds in these boundaries on a boundary are nearest to the storm cells. And you can see sometimes here as you go through this radar loop, other storms actually are forming along that gust front. And you can see that activity here well. So just another example of the conditions and the actual shelf cloud associated with a cluster or squall line of storms. Now, here at Race Point Beach, is a good example of a shelf cloud extending horizon to horizon. Now, a lot of times they're low-hanging clouds, or what we call scud clouds. Very common here because we're near the ocean. And these are often mistaken on a regular basis for funnel clouds or tornadoes, but they're not. They're just cloud fragments associated with the shelf cloud. They can be very scary. Often resemble snowplows or big waves. But the key thing to remember is it's not going to produce tornadic activity, but certainly under the shelf is the strong to damaging winds. And that's what we go at length to explain here in this training, to know the difference. Both are a weather hazard and threat, but they're different. The shelf cloud is again a sign of strong to damaging straight line winds, and then the wall cloud is more of a tornadic feature, which gets us into the next slide where we're going to talk a little bit more about this, which is our supercell storms, the storms that are most likely to produce tornadoes. You need to have wind shear, strong wind shear for supercells, and even with squall lines, you need to have a level of wind shear. This is a kind of a fourth ingredient of severe thunderstorm development. The wind profile and the turning in the atmosphere allows horizontally oriented rolls to develop and kind of get picked up in these cells, and that's what starts the formation of tornadic activity. You need the stronger winds aloft and the turning in height with supercells. When multicells and squall lines, you have strong winds, but it is more unidirectional. And then with unorganized convection, oftentimes, if it's not the instability that's marginal, it's the winds that are marginal. And you can be very unstable, but you don't have the strong winds to tap into, so the storms are more of the single cell or pulse type of variety. So it gives you an idea of the conditions and this ingredient on severe thunderstorm development with these the strong wind shear. You can see in this the diagram here of a supercell. They can have their own shelf cloud associated with it. They often have an overshooting top, and then they often have a rain-free base, which is the interface between the updraft and downdraft region of the storm, and the lowering of the rain-free base is where you can get your wall cloud, funnel cloud, and tornadic development right here. When you're viewing supercells more than 20 miles away, you want to look for that overshooting top that persists for more than 10 minutes, and this anvil here, notice how well-defined and sharp it is. Those are indications of a potential supercell. You can see the main storm tower here, your anvil or tropopause above the main storm tower, your overshooting top. And then when you're close up, less than 10 miles away, you look for a presence of a rain-free base, a low flat cloud base under the main updraft. Look for a presence of a wall cloud, an isolated lowering of the rain-free base that indicates the storm's strongest updraft area. You want to look for persistence for 10 minutes or more and look for rotation. So here's the rain-free base. Here's your wall cloud, funnel cloud if it's aloft, and tornado if it's on the ground, and then the rain and the hail. So this is kind of a diagram diagrammed out with an actual storm situation of an actual supercell. Again, here's your rain-free base. Here's your updraft region, your rain and your downdraft, and right here is your updraft, downdraft region, which is where the most likely development of tornadic activity will be. You need strong environmental winds. You can see the overshooting top, even though there's these strong environmental winds, it just busts through that tropopause. But you can see here, the strong environmental winds are tilting this part of the storm here. So it gives you an idea of why you need those strong environmental winds. And sometimes you can have strong shear, but either too much of it or not enough of the other thunderstorm ingredients, and you don't quite get that level of supercell or severe storm potential because of that. And then, of course, if you don't have the strong winds, the storms kind of just are straight up and down with those weak winds aloft, and what goes up, will come straight down. Maybe you get a brief a severe episode, as we talked about, maybe marginal severe conditions, and then the thunderstorm dissipates and dies here in what we'll call the thunderstorm cemetery. So again, some injected humor from our friends, our forecasters at Weather Service Norton. Supercell thunderstorms, they can last hours. They are the most likely to become severe. They are the least common in the Northeast. Now, it depends on the year. There's some years where we've had several dozen supercells across New England, and then there's other years where we may only have a handful. It just depends on the year. And a specific city or town, yes, you could go years without seeing one. And then in other cases, some towns may have had one or two over a span of 10 years or so. It just depends. Supercell storms produce large hail, gusty winds, tornadoes are all a threat. We talked again, this diagram was shown earlier. Again, that updraft, downdraft region, that's where your wall cloud, funnel cloud, and tornado development is here. And we talked about the well-defined anvil and the overshooting top. If we diagram this out here and we put it on its side and put a radar image superimposed on it, you'll say, okay, well, what part of Kansas, Oklahoma is this from? And I'll tell you, no, it's June 1st, 2011 in Massachusetts. And this here is the supercell that created the EF3 tornado. This here is not precipitation, it is debris. This is what we call a debris ball. Very rare, but in 2011, it was fairly common across many of the severe weather events across our country, and Massachusetts was one of them, where we had a debris ball signature here. This is picking up debris, where we had large hail up to 2-inch in diameter occurring in places like Fiskdale and Sturbridge. Many of the reports were received by amateur radio operators during the event. It was probably the most intense severe weather event we had worked, because not only are you getting a lot of reports, you're getting them in a very short period of time, not to mention all the reports that come in post-event as people are out to assess damage and the storm is safely passed. As I said, we had an amateur operator who at the time was working as a police dispatcher in Munson, who got an emergency report out that their police station had been severely impacted and damaged by the tornado. That information was relayed from the Mount Town repeater to our Weather Service office all over amateur radio. That's how important our role can be in providing critical information during severe weather. So just an example of where we fit in, along with talking a little bit about the storm structure of a supercell. Supercell features, you have a rain-free base, a dark horizontal cloud base with no visible precipitation beneath it. It typically marks the location of the thunderstorm updraft. Tornadoes may develop from wall clouds attached to this rain-free base. So you can see here, here's your rain-free base. The other thing to note here is that it will point toward the rain, whereas squall lines and the associated shelf cloud are going away from the rain. And you can see here in motion here what's happening to the activity here. Here's another example of a wall cloud and abrupt lowering from the rain-free base. This is an example in Leominster. Now, I'll tell you, we can get wall clouds and they don't produce a tornado, but it is a wall cloud. This was an example of one. This was a wall cloud, never produced a tornado, but clearly a wall cloud, no doubt about it. I can recall one event in Connecticut where we had numerous correctly reported wall clouds. We even had a couple of very close to issuing a couple of tornado warnings, issued severe thunderstorm warnings stating a tornado was possible, but it never produced a tornado. And that happens sometimes, and it's just important to get the report correct. But sometimes these conditions, something is lacking, it just never makes it to the ground. When seen up close, many wall clouds will exhibit rapid and upward motion and cyclonic rotation, but not always. And this was a case here on the right. You see here, you're seeing upward motion and cyclonic rotation. This was a case where there was no rotation. And that's another important thing to note when you're spotting when it comes to wall clouds. So maybe asking yourself, we spend a lot of time talking about wall clouds and shelf clouds. So as you might imagine, how important is it? It's very important. And it's important because each cloud feature represents different weather hazards. The wall cloud is a supercell thunderstorm and a possible tornado. A shelf cloud is a squall line with strong straight line winds. Both have their hazards. Both are important to note, but very different weather features between them. That's why it's so important to spot it correctly. If you know the difference, shelf cloud, it's an outflow feature sloping away from the rain. It's associated with a squall line. It's at the leading edge of the storm. It's also a cloud feature that extends from horizon to horizon, whereas a wall cloud is an inflow feature that slopes towards the rain, associated with a supercell. It's at the rear of the storm, and it will not extend from horizon to horizon. So oftentimes spotters and the public will see a shelf cloud and think they're seeing a wall cloud because they think it's a wall of clouds approaching them. But because you've been trained and we've emphasized this, you'll say, no, okay, this is shelf cloud. I don't have to report the shelf cloud is coming, but I'm going to watch out for the strong to damaging winds underneath because I might see trees come down. I might have a wind instrument and I might see wind measurements of criteria that I need to report in. Whereas a wall cloud is something you report, you know the features, you report in, hey, I'm seeing a wall cloud. Note if there's rotation, note the lowering of the wall cloud and whether it's turning into a funnel cloud, things of that nature. So that's how important it is to know the difference and to get it right. And you don't have to be a radar expert to kind of give yourself an idea of what I might be looking at if you're not sure. So if you look here, we have these cells here, and first of all, you'll notice the discreteness of the cells. You'll also notice that they all have hook signatures associated with them. Not all hook echoes produce tornadoes, but every tornado has a hook echo. And you see this feature here, well, you're most likely going to see letter B here. You're most likely to see a wall cloud in this instance. Whereas if you're between A and B and you see this line of storms coming at you and you're out in front of it, you're likely to see a shelf cloud, and you're going to have to be noted around under the shelf cloud is where the strong to damaging winds are. So again, don't have to be a radar expert, and there's a lot of details available in the radar, but just having a high level awareness of, well, these look discrete. I might see a wall cloud here, and well, this is a line, and chances are if I'm out ahead of it, I'm going to see a shelf cloud, and you can put your mind in the right direction regarding what you might be seeing. Shelf cloud versus wall cloud. From a public safety perspective, which do you might think is more important? How about both of them? So for example, here in this video, a lot of outdoor tents and portable equipment here, and the shelf cloud is approaching under the shelf. Could have wind gusts, could be around 40 or 50 miles an hour, could be as high as 60, 70, 80 miles an hour like what we had on Wednesday, October 7th. Definitely a public safety risk from a straight line wind perspective. Whereas down here in the right-hand corner, you see a wall cloud and tornado type of development. And, I think again, both are very important to know. Both have their severe weather hazards, and both are a threat to public safety. You'll see here, wall cloud versus shelf cloud. An example here, upward motion, rotation, and a wall cloud forming. And yes, there is a Florida and Massachusetts. It's in the Berkshires. But you see here, this is horizon to horizon. All these kind of lower hanging clouds, again, with the mountains, it's even more dramatic because higher elevation. But these are just cloud fragments or scud clouds. And this is under the shelf is where the strong and damaging winds will be. So again, another example, wall cloud with rotation, shelf cloud, and the strong winds under the shelf. Shelf cloud versus wall cloud again. This is in Narragansett, Rhode Island. Under the shelf, we had measured wind gusts near 60 miles an hour with this activity and down trees in Narragansett, Rhode Island. There was a tornado warning for this cell, but no tornado had been produced by it. This here in Lincoln, Rhode Island is a wall cloud. This is the cell that went on and produced the tornado on June 23rd, 2015 in Rentham, Massachusetts. This was on July 28th, 2015. And in fact, Jim Palmer, our producer for today's program, actually was at the Weather Service at that time in Taunton, handling the amateur radio station there that day. Again, I mentioned a little bit about a funnel cloud. It's a rotating column of air not in contact with the ground, can be a precursor to tornado development, and sometimes it can look like scud. And this was a good example of this. This was a weak EF0 tornado. It was produced from what we call a cold air funnel down to a few trees and moved some trailers here in this garage. If we didn't have this video, and some hard work from one of our amateur radio operators at the time was involved with Holbrook Emergency Management, we never would have known that this was a tornado. Quite likely would have been classified as straight line winds, but with technology and the ability to capture this was classified as an EF0 tornado. And again, just another example of our importance in the ground truth, and also how technology has helped us document some of these things that I would say even 10, 15 plus years ago likely would have been lost from a records perspective. So something to keep in mind here. Then, of course, a tornado is a violently rotating column of air in contact with the ground. This is Wolcott, Connecticut, July 2014. You can see the tornado is on the ground. What's interesting is this is quite likely looks like a multi-vortex tornado, and I think the bigger part of the vortex is aloft, but you see one of the vortices is on the ground, and that produced the damage. This was an EF0 tornado. I think if the more of the vortex was closer to the ground, this would have been a bigger tornado, but it was an EF0 in Wolcott, Connecticut, and this was on July 27th, 2014. I'll show this video here.
Yep, there it is. It's right here. Guys, we're in the middle of the tornado. Right there in the parking lot. Tornado right in the parking lot.
So I don't know how well that came through, but I thought with the audio here on this one, it would be important. And it's a good tornado awareness thing. So there's a tornado in the parking lot. Great to be able to report it. I'm not sure I would stay around and close to those windows. Any flying debris could crack into those windows and potentially injure you. So this is the case. If you see that, go ahead and report it, but also get out of the way of those windows, or at least in the direct line of those windows where damage could occur and potentially injure you. So wanted to show that video just to give you guys, everybody here, a sense of how sometimes you could go from spotter to having to be safe and prepare yourself and be aware of the situation. And speaking of awareness, if you had a smartphone and saw the storm coming at you on radar, what would you do and where would you go? Anybody remember the Indianapolis State Fair? Some question of how well the grandstand was produced, it was put up and so forth. But again, you see these storms approaching you. You see a little bit of a hint of on the radar of the gust front out ahead of it. Again, strong straight line winds here. You want to be aware and be able to take cover accordingly. So now you know a little bit of the basics of what to look for, and always observe the sky and your surroundings and be an active spotter. This is a scud cloud here in Woburn that actually went on to produce, it got a lot more organized and produced some rotation in a wall cloud. It never touched down. And of course, this was cloud to ground lightning. This was on July 4th, 2012, when the Esplanade was evacuated for a period of time. There were actually a few people that were struck by lightning in this event. We were actually at the Weather Service in Taunton at that time, and Jim Palmer was actually at the Esplanade giving us some reports. This is St. Louis, Missouri, 2011, and we'll see how well this video goes here, but you'll see that the people are kind of milling about at the airport. You'll start to see things change a bit with people starting to run to the bathrooms. I don't know if this store here produced some bad food or something, and that's my own joke. But you'll see here more people taking cover. You'll see the TSA agents running for the bathrooms here. And then you'll see this. And this was from a tornado that struck the St. Louis airport. And the good news was the terminal knew what was the tower knew what was going on, the air traffic control tower, but no one told the terminal. And this was a bit before the wireless emergency alerts on smartphones was more readily available, like it is today. So just being aware of your surroundings and being safe is very important. So ask yourself, where am I and where's the worst of the storm? We never want someone to put themselves in harm's way for a report. So where's the primary threat compared to where I am? Make sure you take cover, but can report in when it's safe to do so. What direction is the storm moving relative to me? And we did one example of this already. We're going to go through several examples of radar versus cloud formations in the next few slides. So radar versus real life. Here's what you're seeing in the picture here. Where might you be here in this image? So if we look, we would be here at number 1. You can kind of see the outflow boundary here ahead of these multicell cluster of severe thunderstorms. And what could you get for weather? Could be strong to damaging winds. A squall line, this is a bow echo here. The upper wind, the winds along a squall line, they may be weaker in some parts and much stronger in others. It's not necessarily uniform strength across the line. In this case here, where it was bowing out and surging forward, that was the strongest part of this squall line. And sometimes at the head of the bow, we can get a smaller type of tornado to develop at the head of the bow where it surges forward. So this is an example here of a squall line. This actually produced significant wind damage across southern New Hampshire. This was back in 1998. Okay, this is another example of a squall line here, produced straight line winds of over 70 miles an hour. And then as it got into the Goshen, Conway area, is where it actually produced a tornado. And you might say, well, what was this, July, August? No, this was February of 2017. First ever recorded tornado in February in Massachusetts on record since 1950. Believe it or not, there had been records of tornadoes in like March and April, but not in February. So if you see here, you'll see the actual tornadic activity here. Again, with the part of the bow, the line here that surges forward, you'll see very quickly here some blues and oranges very close together as it went through Goshen and Conway. That's where significant tree damage occurred. For example, you couldn't get to the center of Conway, and that's an example of how a squall line can also produce a tornado in addition to strong straight line winds. There was a lot of straight line wind damage here in Berkshire County, and more straight line wind damage beyond the tornadic path in Goshen and Conway up through central Franklin County of Massachusetts. And again, this was February. We actually had temperatures in the low 70s, and this actually ushered in a lot of colder air. And believe it or not, in March of 2017, we actually had a classified blizzard. So welcome to New England with its changes of weather. Notice the correlation of the actual shelf cloud to the radar image here. So this person here, you see the an inflow notch and then the storm surging forward. This is actually emphasized curvature here. You see it here on the radar. You can also see it here in the cloud formation. So again, don't have to be a full radar expert, but you can kind of see where you are with relation to the radar and kind of help you understand some of the cloud formations. This is, again, our July 28th, 2015 example. You can see severe thunderstorms moving almost almost due south, south-southeast direction. You can see here the shelf cloud, some cloud fragments here. Again, these are just cloud fragments. Again, under this shelf is the strong and damaging winds, then the rain and the hail. Spotter positioning, back to our June 1st, 2011 example. This storm here is moving from left to right. This is, again, the EF3 tornado that affected the Springfield area into Munson and into Sturbridge. This person here, this storm is actually moving away from them. So they're in a good, safe place to spot it. They can say the tornado's on the ground. They can say it's doing damage. They don't necessarily know the extent of the damage, but they can clearly spot the tornado and keep an eye on it in a very safe location. This position here is a little more problematic. Now, as I said, this storm in here is moving left to right. But sometimes these storms will do what we call right move or dive southeast. And if this dives southeast, this person is going to have to take cover quickly. So this is a case where reporting it, you can see it's on the ground, you see some debris in the air. Again, don't know the extent of the damage, but this is a case where you may want to take cover because it hasn't passed you by yet. And if it turns directions, it could come right toward you. So an example of a more precarious position to spot from. In this case here, again, the tornado is moving from left to right in a west-east direction. Here's a location they may get the hail. They may see some strong winds, certainly could get large hail along with the heavy rain, but they're not going to be in a good position to actually observe the tornado itself unless it changes direction. So just an example there of that spotter position. And then this person here, they're kind of on the northern edge of it. Again, unless it moves in this direction, they're not in a good position to see the tornado, not to mention the obstructions and buildings and trees and such that they have at that location. And that same is true in the last slide as well. This Worcester example, this is night vision imagery here from Michael Rossiker, who actually lost his home in the EF3 tornado on June 1st, 2011 in Munson. Well, he's in Worcester, and he actually spotted a tornado here as well. He had wind gusts over 40 miles per hour to his exact location. You can kind of see towards the end here that a brief touchdown of a tornado in the city of Worcester. We were at the amateur radio station at the Weather Service, in fact, training a couple of new amateurs to operate from the station there, and we were getting a lot of reports of rain and flooding. These heavy rains here were producing rain over 3 inches an hour. As I got into the Worcester area, the radar operator, who's our warning coordination meteorologist, who's also an amateur operator, Glenn Field, turned to us and said, "I'm interested in the winds in the Worcester area." And I apologize for the weather message interrupt for the wind advisory. You'll see here that the storm went through the Worcester area. We had 2 amateur operator reports. One was from a security guard at the Clark University who had his portable amateur radio with him saying, "We have very high winds. It just flipped over the goal netting of the soccer field." We had another amateur operator who was traveling to his home in Millbury in a part of Worcester saying, "I have trees down, including one tree that went flying in the air." That prompted a tornado warning. Tornado was just probably on, it was on the ground and just lifting as the warning went out. And within about 4 hours, we confirmed an EF0 tornado. The tornado warning was initiated by the spotter reports. It was also a situation where a lot of the damage reports that we received from the net provided the areas to go look to assess the damage and come up with the tornado path. And this received a lot of media publicity about the importance of Skywarn spotters and amateur radio operators and the work that we do. This is an example in Revere. Now, this tornado was rain wrapped. This was Revere. This was July 28th, 2014. This is an example where we did not get a lot of spotter reports. A lot of spotter reports of flooding, but not reports of high winds or any type of tornadic activity. There was a severe thunderstorm warning out, and then they let it lapse because there were no wind damage reports. We did get a lot of damage reports out of Revere. This was actually where a tornado had touched down. This was an EF2 tornado. Only lasted about 4 minutes. We did find out later, about 6 hours later, there was wind damage in Needham, Massachusetts. And we also had some amateur operators on Brookline who thought they had saw rotation. They weren't quite sure. And didn't report it. So this is the case where the spotter reports may have at least resulted in a continuation of the severe thunderstorm warning to the area. There was a tornado warning out up and through the North Shore. They did have wind damage in those areas, but it was from straight line winds. And now this is the Wolcott, Connecticut example. This is a case where, first of all, the radar is not all that impressive. I wouldn't necessarily be looking at this and expecting tornadic activity, though I do see a little bit of a hint of things here, maybe what we would call a bounded weak echo region, or maybe a very slight hook there. First off, this person, they can see upward motion and rotation, but can't really see if it's on the ground or not. They might be able to change their position safely to determine something. But here I would just report rotation and potentially a wall cloud here with this person's positioning and reporting here. So we are at the break here. It's about 10:07. We'll just take a quick 5-minute break, allow folks to get up and for a few minutes, and then we'll proceed with the second part of the program, where we'll talk about reporting and other things. And Jim, I see you up on the screen here. So is there anything you'd like to add?
Yeah, thanks, Rob. So we've had a couple of questions come through the first half, and I've done my best to answer the first one, but I figured it'd be good to pass on. So the first question was for the storm we had on October 7th. I could visually see the clouds coming in and suddenly rain, wind, and trees falling. Was that considered a shelf cloud? And obviously, as we saw during the presentation, shelf clouds do last from horizon to horizon. So if you're getting your strongest winds as that's coming through on the leading edge, then I would say it's likely coming from the shelf cloud. And give it to you, Rob, in case you got anything to add there.
Yeah, no, definitely. That's an excellent observation. You know, that and it's exactly what can happen, especially with a strong squall line. You see that shelf cloud come in, and then those winds increase rapidly, and then you get the rain and the hail. And sometimes with the rain and the hail, the winds will continue as well. But exactly, the strongest winds are right along that leading edge, and then potentially as the rain and hail initially starts in these storms.
Okay, great. And second question we had, just I thought this would be an excellent question to answer for everybody. And we're going to cover some of this in the second half, but question from KC1NPK. I'm not involved in Skywarn myself, so I'm wondering how someone gets started. I've mentioned it to my daughter and she's interested, so where does she begin? And we've also had some questions about the recording for the public, but how does one get involved in the Skywarn program?
Well, you're taking a great first step with this training. This training, as I said, it depends. I'm not sure of your location, so other offices may differ, but at our office, when we complete the second part of the training, you'll see a link for the online quiz. And once you take that, you'll be registered as a spotter. And we'll also talk a little bit about frequency information for Skywarn in Southern New England. There are similar links for other parts of the area. You know, the Gray Main office in particular comes to mind, also the Brookhaven and Caribou and offices. Frequencies out in Vermont are likely tied to Aries and Races in that state. Once you're registered as a spotter, you can participate without the spotter ID, but we like to get folks trained up. And when we know that they're trained up, it just gives that much more credence to the reporting. We'll also talk more about how you can report in via the various amateur radio methods, via our social media. And when you take the quiz, you also get a spotter ID number and a special spotter phone line to call in reports.
Okay, great. That's all we got for questions that have come in through the Q&A. As always, if anybody has any questions, please feel free to drop those into the question and answer section. And actually, we'll just get another one. We'll answer live. Can spotters report in multiple areas? That's coming from Tim. And I guess it depends on which area you're from. So obviously, Southern New England, you can report anywhere in Southern New England. If you're from a different office, I think the procedure might verify. You can always call us here and we'll relay to the appropriate weather office. Over to you, Rob.
Yep, yeah. If you're here in New England, and also if you get trained by our office, other offices in New England and like the Brookhaven and Albany offices, they will accept the training. If you're going out to like Florida or Texas, that might be a bit different, but certainly across New York, New England, and probably in the parts of the Mid-Atlantic, our training would also work for other offices. And if you're, you report into our office and you're not from area, we get those reports into the appropriate weather service office, and then vice versa. There's been times other offices have had reports come in to their area, and they've relayed into our office.
Okay, great. So that's what we got for open questions. Again, feel free to keep using that feature to let us know if you get any questions, and if time permits towards the end of the training, we can certainly do some interactive Q&A. But for now, thanks to everybody for joining us, and we'll take a few minutes for the break here.
Yeah, we'll take about a 5-minute break. It's 10:12 now. We'll come back at like 10:17. I do think we're running a little bit over a 2-hour window. This training is generally about a little over 2 hours at times, sometimes up to 2 hours, 15 minutes. I actually noticed I've run a little bit longer on the online sessions. So we'll come back in about 5 minutes, give people a chance to stretch and anything else they may need to do in a few minutes, and then we'll be back here at about 10:17, 10:18 here, and we'll start part 2 of the program. All right, we're back, guys, and thanks for everybody. It took a couple extra minutes, but I wanted to get the second part up here. Jim, anything we want to address before we begin the second part of the program?
Sure, we've had a couple of questions came in through the break. A lot of thank yous for being here today. We appreciate everybody joining us. So one question which I thought, Rob, you might want to address directly. Is there an app which can relay images, lat-long bearing specific categorized conditions? Also thinking machine learning of cloud formations from spotter images could be useful for immediate verifications. Why don't you take that one away?
You notice how Jim started smiling, because that's an exciting topic. We are working on something now. Honestly, with this past year and the way things have gone, we have not done much work on it lately, but we are working on such technology. And honestly, it's a little bit orthogonal to amateur radio and the weather service, but we are working on an app to do that, and a web portal and app kind of comprehensive system to do that. It was a project we started with some college students, and we're looking to bring up, and I think we'd start here in the Northeast and New England in particular, and then move across the country. We actually have a trademark for it. We're calling it Weather Vault, kind of a vault for all kind of weather, ground truth, surface observations, things of that nature. As I said, it's been delayed. We were hoping to get it out, maybe even, I would arguably say maybe about a year and a half ago. It is kind of a part-time project that we've been working on. We're looking to develop both an app and website portal for it, because I think we have some folks that are more comfortable on a computer, other folks more comfortable with phones. Obviously, the advantage of the phones is the location aspect, being able to grab things, but also centralizing a lot of the weather imagery of ground truth that exists out there. And especially, Jim can tell you, because we produce, and we haven't done some more recently here, and I think it's a project that we'll probably get into as we get into the winter. Given where we're at with COVID, it allows, some of our things that we typically do, we can't do. Other things that we can do, that we would like to do, we can never get to, we can do those things. And one of them will be Skywarn videos. We are now getting more imagery into us from amateur operators and spotters and such than we ever have. And it's, I think, going to just continue to grow. And it would be great to really document these events more clearly. There's perception out there, I think, that people don't think we get these kinds of severe weather events here and such. And I think part of what we can do, not only from a near real-time reporting perspective, is also the archival and expansion of these and documentation of these incidents. So, and to your point, can also be cloud formations, but also the damage part of the events. Imagine if we could take a severe thunderstorm warning and say, this is the kind of damage you get, and it's more marginal, versus a more higher end severe thunderstorm warning and say, this is the kind of damage you could see, and it's a lot more significant. I think it would help the public better understand what they might get for severe weather. I've spent a couple extra minutes on this because it's something I'm very passionate about doing. And as I said, it's been a project we've been working in the background, and something we would like to get more into over time here. It is something that we're interested in doing. And I think here in New England, this is one of the things I think the amateur radio community, the non-amateur radio spotters, just a very high interest in weather in this region. And I think this is an area where I think we can really lead the way in this effort to do some of the things I've been talking about. And amateur radio plays a huge role in that. And further, we talk about it through an app on the phone and such. How about some of our digital amateur radio technologies and integrating that into it? And if it's driven by us and by folks that have amateur radio backgrounds, right, we can help control that aspect of it as well. So, I think I answered your question. May have been more detailed than you wanted, but you definitely hit a topic I'm very passionate about, and something that we're definitely interested in looking at doing. And if folks, it's interesting if some folks have some development app web experience and stuff. It might be something we could talk to folks about and helping to do. As I said, we do have a framework for it. We're a little bit more ahead on the Apple side than the Droid side right now, just based on some of the folks that have been working on this. And we have some capabilities on the website as well. So I'll leave it at that because I probably spent about 5 minutes talking about that. Jim, any other questions?
Nope, no other questions. As we move through the second half of the presentation, please feel free to keep entering those questions into the Q&A box. We'll try to answer as many as we can live and then review towards the end of the presentation. So over to you, Rob. All
right. So if it were that easy, meaning, from a spotting standpoint, if it were only that easy to spot here in southern New England. So spotting in New England, there's a powerful cloud formation. Well, we got trees to contend with, animals. I mean, you can't necessarily chase down Route 128 or in Massachusetts, or I-95 in the summertime up in New Hampshire and Maine, particularly on the weekends with the travel. This is Windsor, Connecticut, July 1st, 2013. This was a tornado that occurred. This is a tobacco netting that flew across Interstate 91. You could see the person had the tornado visualized and then kind of got distracted by the flying debris. Kind of understandable, right? We don't see tornadoes all that often here, so easy to get distracted. But you want to kind of keep your eye on where the tornado is and where did it go? Did it kind of get shrouded in the precipitation and so forth? Spotting in New England. So this is Lincoln, Rhode Island. This is a wall cloud here. We got trees in the way. So this was actually coming into TV stations that there's a tornado on the ground. Well, how can you tell? I'd be willing to buy off that this looks like a wall cloud, but I wouldn't be ready to buy off that it's a anything really more than that from this picture here. So I don't know what it is beyond that point. Rain wrap tornado. It's common for New England tornadoes to be wrapped in rain. This one is just a little bit further west of New England in Amsterdam, New York, just outside Albany. And you can see here, there's a tornado and some folks are kind of driving right into it. Some are avoiding it and some are driving right into it. Very hard to see the tornado in this type of situation. The Great Barrington, Mass tornado of 1995 was like this. I had mentioned the Revere tornado in 2014 was similar. So just something to keep in mind how our tornadoes can be rain wrapped. Water spouts, in fair weather, they're generally between 30 to 60 miles per hour and can form from water to cloud or cloud to water. Water spouts by their nature form over water. Those are fairly rare here in New England. We have had water spouts, the tornadic ones, form just like tornadoes, just over the water with rotation in the storm and winds of 65 miles per hour or higher. We've had a number of these. If you look at the Cape Cod tornadoes, they were water spouts that over water that came over land. The one Rhode Island tornado we had in Portsmouth was a water spout that came over land. 2008, we had a number of water spouts, including one not far from where I live in New Bedford, Massachusetts, in Dartmouth in Padenham Harbor. So we have, a number of, I've had a number of tornadic water spouts over the years. Microbursts, a sudden outrush of wind from a thunderstorm, which produces straight line wind damage. It lasts than 5 minutes and affects an area less than 2.5 miles wide. This is an example here on June 5th, 2010 at Bradley Airport. It's sped up in a time lapse, but you can see we had wind gusts at Bradley over 70 miles an hour, and a number of damage reports in Hartford County, in Talon County, Connecticut. That was a very busy severe weather weekend in 2010. June 5th and 6th, we had tornado watches for portions of our coverage area. We had significant severe weather both those days, including on June 6th. That was the event where we had what we call a macro burst, which is a microburst but greater than 2.5 miles wide, affect the greater Boston area. In fact, one of the organizers of the Aries Academy, Phil Temples, was living in an apartment complex that lost part of its roof, and he reported it to us when it was safe to do so, and he was pretty shooken up by it, and the pictures were pretty dramatic. And that was a case where Boston, Mass really got into weather preparedness after that incident. They really, they were like, well, if this can happen with severe thunderstorms that lasted 10 to 15 minutes, what happens in a tropical storm or hurricane or bigger situation? And Boston really ramped up their weather preparedness after that incident. So this was a, like I said, a pretty formidable weekend of severe weather, and gives you a little more description of microbursts as well as macrobursts. Now, interestingly, here with a few years ago, right around this time of year, we had this was October 8th, 2014, where Mount Tom had a microburst. We had trees down reported in East Hampton on Mountain Road. This happened around a little after 5 a.m. on that October 8th. And the Barnes Air Force Base had a 48-knot, 56-mile-an-hour wind gust. You can see in the video here, it was not just trees down on Mountain Road. It was the side of Mount Tom Mountain that had trees down. Interestingly, right, we had the severe weather outbreak October 7th. Mount Tom had an 88-mile-an-hour wind gust from that squall line of storms that was just recently put in the local storm report. So just give you an example, we can get severe weather even into this early October timeframe. Look-alike clouds, cloud fragments that briefly resemble funnel clouds or tornadoes and hang low at the base of parent storms. So this is an example of Scud cloud, and that's not an acronym, that's the name of the cloud. It's a Scud cloud or cloud fragment. It looks has a funnel shape, but there's no rotation, there's no movement. These are the lookalikes that get folks confused and get reports of tornadoes that are not there. Another example here, this is a rain shaft. There's actually downward motion to the ground. That's a rain shaft. Here, the white area here, that's a hail shaft. And so again, trying to give you examples of things that can look like something that they aren't, and give you that kind of reference to look for these things. This is Wallingford, Connecticut. Again, not really attached to the high cloud here. This is just scud and low-hanging clouds again. Very hard to determine things with this. Here's an example. This looks like it's touching the ground, but this is fog and low-hanging clouds and scud clouds and fragments here. This is again and we see this a lot here, especially with us being near the ocean. This cloud formation here looks, in this one here, it looks like it's right on the rain-free base of this thunderstorm. You can see here, the imagery is a little blurry, but you can see that it's not really connected up here to the cloud, nor is it hanging all that low. This is just another example of a cloud feature. It makes for great photography, but not anything that's tornadic. In this case here, we're looking likely at the shelf cloud along that supercell that produced the tornado momentum. Notice the rain is behind it. This is moving from left to right. So again, not to mention the trees in the way, not much to really see here. And again, this was an example of some of the reports that come in from the general public that look like tornadic activity that it's not. I'll play this here for safety. Use common sense because you don't want to be caught in the wrong place at the wrong time. Yes, you might want to get away from the bull. And you might not want to pull on the bull's tail. So a little bit of humor, but to emphasize the importance of safety. So tornado safety indoors, you want to shelter and find a place to take cover using the duck principle, down to the lowest level, under something sturdy, cover your head, keep in shelter until the storm has passed. You want a first aid kit, shoes, and a whistle where that is. And you say, well, when is that going to happen? This is New England. Well, it happened on June 1st. It's clearly the type of damage, the type of damage we had, the destruction of homes. This was a very serious event, and these simple tips of if you have a basement, going there and having just the basics of a first aid kit, shoes for if you have to walk through debris, and a whistle is just can be important, and some very basic things that you can prepare that can help you if struck by a very severe weather incident or a tornado. In cars, I know a lot of people say, oh, an underpass is a good place. That can be a very bad place because the winds can actually accelerate under the underpass through the Bernoulli effect if a tornado gets close enough. So what the Weather Service advises is get out of a vehicle and get into a ditch or ravine if there's no reinforced structure nearby. Reinforced structure, if possible, would be best. As a last resort, if a ditch isn't near, buckle in and lower your head below window level. And that is the best that you can offer. In a car, it can be very dangerous. I mean, if the underpass is well away from the tornado, maybe that's okay. But if it's too close to the tornado, it can actually be worse for you to be under that. And that used to be passed around a lot, that video of people hiding under the underpass. And notice how strong those winds were. If anybody recalls that video that I used to see quite a bit in the 80s and 90s. Again, not the best thing to do. And this is the other thing you got to worry about. This was in Cookeville, Tennessee, March 3rd, 2020. What debris can do here, this 2x4 right through the windshield of this car here. So some tornado shelter guidelines, the worst options are mobile homes, vehicles, and you see underneath a highway overpass. The large rooms are not good either, but an interior room on the lowest floor, like a bathroom or a closet. Basement is even better. And then obviously there's tornado storm shelters, probably unlikely to have here, but this is just to give you an idea of tornado sheltering guidelines and the best available refuge area to use when a tornado warning is issued. In 2019, there were 20 fatalities for lightning across the country, 0 in southern New England, 82 people injured in 2018, 0 in southern New England. Now, folks can be treated if they are struck by lightning, but when thunder roars, go indoors and stay indoors until 30 minutes after the final clap of thunder, because lightning can strike a good 20 miles away from the storm center. So you want to be careful not to go back outside too quickly after a thunderstorm, and lightning is the #2 weather-related killer. So something to keep in mind. High wind and safety, use common sense, know where you are in relation to the storm, and stay away from windows. These pictures here are from August 4th, 2015. Boston had its highest ever recorded hail of to 2 inches in diameter. This damaged cars, it damaged homes, roofs, and windows. That was the second round of severe weather on August 4th. The first round was a damaging wind event across Rhode Island and Southeast Mass, the strongest in Rhode Island, but extended well into Southeast Mass. There was actually also a rogue storm that produced a microburst up in the North Shore, up in parts of Wakefield and Peabody, that Jim documented along with Al, W1PLK. This was a kind of a 2-round day of severe weather back in 2015 on August 4th. And you see the down trees in West Warwick, Rhode Island here. So just some examples of high wind and hail safety. I'll put this video in motion. I don't know how well it'll go through here, but flooding safety, turn around, don't drown. 6 inches of swiftly moving water can knock an adult off his or her feet, and 2 feet of water can make most cars and trucks float away. So when flooding ahead, turn around, don't drown. And with some cars, if it's a zip car, it might be 6 inches of water that can get it moving. Again, just some flooding safety tips to keep in mind. In this video here is an example from Tropical Storm Irene in southern Vermont. Hurricane safety, we were very lucky in New England that we only had Tropical Storm Isaias, although that was quite formidable in southern New England, especially in western Massachusetts, Connecticut, and Rhode Island with the damaging winds. Any tropical system with a name in and around the Bahamas has the potential to quickly affect New England. The Isaias was a good example of that. Do not concentrate where the eye is going to make landfall. The hazards can be well beyond the center. That is another good example from Isaias earlier this year, even though it was just a tropical storm when it affected us. The wind effects were well north and east of the area with severe weather and damaging winds. Be aware of where you are with respect to the track of the eye. So the center of Isaias and the eye went to our west with its large wind field. We were on the less rain, but the significant wind and severe weather side of the system. You want to run from the water and hide from the wind, and be prepared because it's important to be able to be self-sufficient for 3+ days. So just some hurricane safety tips to keep in mind here. We are approaching winter, so some winter safety. You want to winterize your disaster kit in your home and car and have a plan in place to gather info about the hazards, meet with your family to create, implement, practice, and maintain your plan. You want to know what to do if you're caught driving outside, hypothermia, frostbite, if you're stuck in your vehicle, having some provisions in case you have to be in your car for an extended period of time. These are all things to consider if you have to travel in the winter, and some important winter safety tips to talk about. So now you know how to be aware and to be safe. As I said, we haven't even told you what the reporting criteria is yet. So now we're going to tell you what to look for while spotting, and the spotter's role. What do you report? So what does the Weather Service consider severe? We mentioned lightning is the #2 related killer, and let's say there's thousands of lightning strikes per minute, and there's 500 house fires due to lightning. Is that severe by Weather Service definition? And the answer is no. And you say, well, how can that be? Lightning, it's #2 weather related killer and so forth. It's because even the weakest thunderstorms can produce a lot of lightning. So they'll produce a special weather statement to cover the lightning hazard and such, but it's not severe by Weather Service definition. 50 inches of rain in an hour. We want to hear about it. It's going to cause epic flooding that'll keep the Weather Service hydrologists busy, but it's not going to prompt a severe thunderstorm warning. We can have heavy rain over an area and it not necessarily be thunderstorm related. So it's not severe, but it's definitely going to prompt flash flood warnings. It could prompt a flash flood emergency. We want to get all the reports on the flooding, but it's not going to prompt a severe thunderstorm warning. Severe, it has a special connotation with the Weather Service. That means winds greater than or equal to 50 miles an hour, 58 miles an hour, excuse me. Hail greater than or equal to 1 inch. That used to be 3/4 inch, but it is now 1 inch. And then a tornado or widespread damage. These are examples of what severe means to the Weather Service. And again, we want to hear about house fires due to lightning, injuries due to lightning, or hopefully not, but fatalities. We want to hear about flash flooding and such, but they're different categories of reporting. They are not severe. We want to get all those reports, but it's different from actually what the Weather Service considers severe. Weather reporting uses the tell method, the time of the event type, the location of view, the location of the weather event. At 6 p.m., I observed a wall cloud. I am about 5 miles south of Boston looking to my northwest. It's an example. Here's a bad example. Ohio looking up at the sky. Well, that doesn't tell us a lot about what's going on. We know the sky's up there, but what's your location, and what direction are you looking, and so forth. It prompts all these questions. The 3 W's of reporting: what type of event occurred? The hail can be a range of sizes, but if you give that, that's fine. Make sure you note the largest hailstone. The wind, report the highest gust. And then when did the event happen? Currently, 5 minutes ago. Where are you located, and where did it happen? Reporting a tornado, as tornado funnel or wall cloud. You can see here a wall cloud formation here, funnel cloud formation here, and this is the actual tornado on the ground. These are all from June 1st, the Springfield tornado incident. You'll see water here picked up from the Connecticut River. We prefer reports in real time, but we'll take them anytime. That's one of the things that we are talking about is, even here with this October 7th event, even reports and photos and imagery we get after the fact is very important. It may help make the determination of what type of system is it. Was it just a strong mesoscale convective system, or is it teetering across the line into a derecho event? That's what that information tells us. Reporting high winds, we want to know about healthy branches 4 inches in diameter or larger down, larger trees down. We mentioned severe is 58 miles an hour or greater, but we like to get reports that measured gusts of 40 miles an hour or greater. Part of that is because if you're getting a 40-mile-an-hour gust in one part of the area, another area may get much stronger winds. The other thing is we know that a lot of weather stations are obstructed to an extent. Sometimes getting wind gusts of 40 miles an hour or greater can be indicative of winds that are even stronger that just aren't being measured in a given area. So any kind of building damage, power lines down, trees down, again, reports in real time we'll take, but we'll are the best, but we can grab reports at any time for a given event. Hail, we're looking at pea size or larger, basically an 1/8 inch in diameter or larger. We used to say any size hail, and then some conscientious spotters in an area tried to tell us they had sand size hail. So we kind of put a little bit of a lower limit now to reporting any hail. Severe is 1 inch or more, but we'll take hail reports of even 1/8 inch in diameter, because it may tell us, again, if you're getting 1/8 inch hail where you are, in another part of town, they may be getting golf ball size hail. So that's why we want reports of hail of at least about an 1/8 inch pea size or so and larger. Prefer reports in inches, but can use common objects like coins, athletic items, food. But please don't use marble size hail, because it's just different size marbles. Officially by Weather Service classification, that's 1/2 inch. Every time we get a marble size hail report, we kind of go back and forth to get a sense of the hail size. We refer the reports in real time, but again, anytime we get reports, it can be beneficial. Reporting rainfall, 2 inches or more anytime, or 1 inch or more if it occurs in an hour or less. It always has to be through a rain gauge. It can be the nice fancy Davis weather station or the weather flow data weather station, but it can also be for $30 one of the what we call the Coco RAS rain gauge. And that's a very good gauge. It can be a plastic rain gauge that you get at a hardware store, properly mounted. It does not have to be a sophisticated rain gauge device, but something that has the right corrugated measurements on it and so forth. So again, doesn't have to be an expensive instrument. And then any observed river, small stream flooding, stream out of its banks. And you saw the example of some flooding here in Provincetown and Brookline, Mass. This was from the Mother's Day floods in North Shore in Massachusetts in 2006. Alternate transportation, person canoeing near the market basket that is sandbagged off in Lawrence, Mass. Reporting flooding. So cars floating. This is at the Bridge of Flowers during Irene up in the Deerfield Greenfield area. Definitely something we want to hear about here. Now we want to be specific though. See, right here this is a road that is gone. This is a road washout, meaning the road is gone. If there's water over the roadway, that's not a washout. If it reaches the right depths, we want to hear that reported, but report it correctly. Here is a road washout. The road is completely gone. And you saw up here the cars floating example. Reporting street flooding. So 6 inches or more of water depth across the whole road, a road closed due to flooding. This example here is from a friend of mine. This was I work at Dell Technologies, was EMC Corporation. You see here, this is flooding in a parking lot area that you can see the water up to the bumpers of cars. This is criteria reporting for flooding. Jim took this picture here, and there's a couple inches of water over the parking lot. This would not be reportable. However, the rain continued here, and this picture here kind of turned into this picture later in this event. This was, I believe, in 2010, March 2010. So I wouldn't report this, but if you're seeing this type of thing and it's still heavily raining, and you check, it might be good to check back this area in a few hours, because it could turn into what's on the left-hand side of the picture here. So just an example, some examples of street flooding. And then reporting winter storms, you'll see ice jams that block upstream of rivers. Sometimes that happens. And then obviously we have the snow, the ice storm here from December of 2008, and any kind of coastal flooding along the shore. We'll talk a bit more about reporting criteria here as we move forward. And of course, as we approach the winter season, New England, here in New England, alert snowstorm watchers know what to look for. Here's the light snowstorm, the moderate snowstorm, and the nor'easter. So the different snowstorm indicators for the given area. And of course, Jim could talk at length, if folks want to, about the French toast emergency scale that comes out in the Boston area. Reporting ice jams, just how much of the river is blocked. Is it near any rivers and bends? Is it causing any flooding over a given area? I recall some ice jam flooding along the Ware River that we documented. Any flooding upstream due to the jam, and what happens if and when the jam breaks can cause significant flooding and possibly damage to a given area. More common out in Western Mass, Western Connecticut, through Northern Mass, and up through parts of Northern New England. Reporting snow, we want folks to report when at least 2 inches has fallen, and if you get an inch or more in an hour, and report a final total at the end of the storm. The final total is very important because sometimes with our bigger winter events, when FEMA disaster declarations occur, the only reports that are accepted for that criteria for disaster declarations is from Skywarn spotters, co-op observers, COCO-RAS observers, amateur radio operators, not from the general public. So it's just something to keep in mind. Snow squalls, they can result in rapidly changing weather conditions that can cause accidents and such. Thunder snow, certainly Jim Cantori's favorite item. We want to hear about that, and a quick change from rain to snow or back. So some examples here of reporting during snow events that we like to get, and you see here some of the examples in Connecticut on the heavy snow. We'll spend one slide on snow squalls. Again, intense, short-lived burst of heavy snowfall. A lot of times these can cause accidents because the weather conditions can change so rapidly. Similar to blizzard conditions, but localized, usually last about an hour or less. Can often cause chain reaction accidents resulting in injuries or deaths. So from a reporting standpoint, there is the new snow squall warning, which has been issued a few times now over the last couple of years. Quick reduction in visibility to less than quarter mile, and snowfall accumulation. Usually it's in less than an inch of snow, but sometimes it can be up to about 2 or 3 inches. And if it occurs in a rapid way, it can turn roads from dry to wet to very icy conditions, and that's what causes a lot of the accidents. So we've come up with a little bit of a criteria working with the forecasters in Norton. Visibility less than a quarter mile, and this is the case for pictures, videos of the snow squalls. Right now sent through social media and email, and we talked a little bit about the app idea we're working on. That'll be another way to get the information out, will be very useful. The heavy snow and any accumulation from it, and then accidents due to the snow squalls. Even though we may not 100% know that it's snow squall related, we document those incidents. They can be researched afterwards. The snow squall warning is just another way to kind of advise people of a rapidly changing weather situation that can cause issues. Measuring snow, you want to find a clear, flat, open area away from trees and buildings. You want to take several measurements around the area, avoid drifts and bare spots, and report the average value. If you give us a snowfall report of 5 1/4 inches, we'll round it up to the nearest tenth. So with rainfall, we go into hundredths. With snowfall, we round up to the nearest tenth. So that's how measuring snowfall works. You do not need to clear your spot, but if you do, wait 6 hours between cleanings, because we want to measure snowfall accumulation versus a snowfall rate. I think the clearing of the cleaning in a 6-hour interval is most important when we get the really heavy, wet, sticky snow that has a tendency to compact a bit, and has a tendency to be have a damaging component to them with that heavy wetness of the snow. So and when we have the temperatures right around the freezing area. So that would be the most important case to clear a spot if you do it at all on that 6-hour interval. Now, ice accretion, this has become a bit more complicated to explain. They've done some things here. So the Weather Service measuring method you see up top, you simply report the measured value in this instance. In this instance here, where the ice is uneven, you can take the whole number here, then divide by 0.4 before reporting. This is how we're trying. This is a bit of a change in the ice reporting that is trying to be addressed. For example, if an ice accumulation forecast is 1 inch, that equals a mean radial ice thickness forecast of 0.4 inches. This is something that has changed quite a bit here in reporting year over year. So I think this is the most simplest way to explain it. I did explain this at the last session that I did, and I know there were a few more questions, so I'm going to keep it, kind of very basic to what's on the left-hand side of the screen here. So if you're measuring radially, measure from the edge of the object to the edge of the ice. If it's uneven like the image to the left, measure on both sides and take an average, and then divide by 0.4 and report. And then also report a change between rain, snow, sleet, or freezing rain. Coastal flooding, we want to hear about any type of coastal flooding that affects the shore roads, splash over from the sea walls and such, any kind of structural damage or beach erosion. We definitely want to hear about those things from a coastal flood standpoint. And then reporting during hurricanes, or for that matter, tropical storms, it's all the same reporting criteria. Rainfall, so we can assess flooding potential. Wind, where instruments are still available. Any downed trees, any downed power lines, any structural damage. Stream flooding, coastal flooding, and the extent. And remember, safety is number one. We don't want you to put yourself in harm's way for a report. False reports, false warnings equal no actions that will result in fatalities or injuries. So it's very important that we're precise. Take a deep breath and report only what you see, not what you think you see or wanted to see. In terms of what you heard someone else saw, we do a lot of public safety reporting relaying, and if it's done properly, it's very effective. And if we know the source of the reports, we can go track that down. I'll give you an example from the Wednesday severe weather outbreak. We received a report off of Northeast Fire Association social media feed of 5 injuries in Fort Devens, Massachusetts. We gave that to the Weather Service, and we told them, look, probably check in with local Fort Devens public safety to get the details. And we confirmed 5 injuries. They were all treated and released, so they were relatively minor injuries. One did have a concussion that he was treated for a bit long for in the hospital, but was also released. It was part of a military training item. They were ordered to hold down the tent when the winds hit, but the winds were so strong they could not keep the tent held up. And one was thrown down the embankment. The other 4 more scrapes and injuries from the tent collapsing. So, but this is an example of how we can report from other sources, give them the sources and have it, and then track down that information. And it's important. That's another thing that'll be important in determining the extent of the winds with that severe weather situation. So keep that in mind, and remember, stay calm. And again, if you're observing directly, report what you see, not what you think or wanted to see. Because with Skywarn spotters, when it's a Skywarn spotter report, the media pretty much takes it as it's very reliable. A lot of people are listening to what we're saying. The media really understands when it comes from an amateur radio or non-amateur radio Skywarn spotter, they believe it comes from somebody trained and that the reporting is precise. Some reporting do's or don'ts. Here on the right, we want to hear the report. The splash over here, seaweed and debris in the road. We want to hear about this. On the left-hand side, we have a little bit of standing water in the travel lane, but not enough to substantiate a report here. If it was covering more of the lane and up to 6 inches in depth, we would definitely want to consider that a report, but not in this case. Same thing here on the left-hand side. This might have been worse flooding earlier, but by the time Mara got to this flooding area here, this is not considered reportable. On the right-hand side, this is a mudslide from flooding. So clearly, we want to get that reported. Reporting do's and don'ts on the winds. We don't want to hear about the small branches and twigs, but trees like this and large branches of this size here that I'm pointing out, and maybe this size here, we definitely want to hear about those. However, if the twigs are down by ice, we want to hear about it, and then that's a great way to report the ice thickness. So something to keep in mind on the smaller twigs and branches. On the winds, don't worry about whether it's a microburst, a macroburst, or what it is. Just report that the trees are down due to the winds. So I have several 10-inch diameter trees down due to the strong winds from the passing storm. And maybe note your street location and city, of course, through the TELL principle. Reporting do's and don'ts on clouds. So this is an example here. I'm seeing some upward motion here, but I'm not sure how well connected it is to the cloud base. So I wouldn't report it yet. I'd watch it carefully. I'd look to see if it gets more connected. I'd look to see if there's more rotation and such, but I would not report this in right away, but it's something I would watch carefully. This example here is in England. It looks like a funnel type shape here, but it kind of looks like it's on the edge of the storm here. Don't see much upward motion and rotation. I would watch it. I wouldn't necessarily report in straight away here. You know, again, doesn't look all that ominous, but again, something I would watch and just see how it develops. And this flying by here is a bird. It's not debris, but something to keep in mind in watching with cloud formations here. Reporting do's and don'ts on lightning. Don't report to us that there's a lot of lightning. Do be aware of the lightning threat. And if there's house fires from lightning, any known injuries or fatalities from the lightning, we do want to hear about that. Lightning is the underrated and #2 weather-related killer. We talked a lot about preparedness, websites, social media, web and mobile apps, reporting, the tell method, time of the event, event type, location of view, location of the event, and then have plans in place for the different weather hazards. You know, gather the info on the hazards and then meet with your family to create, implement, practice, and maintain your plan. So after you take the quiz if it's with our office, we do give a 1-800 number for the spotter ID. Don't call 911 unless it's a significant incident, and we'll actually hit an example of that. There is a web-based reporting form. It is not good for reporting a tornado on the ground or short-fused information about wind damage from severe thunderstorms. It's really more geared to rainfall and snowfall. As I said, we're looking at other technology that uses an app and such for some of that reporting. List of frequencies, just go to wx1box.org. Ignore this part of the link. Just go to wx1box.org, and on the menu section, a drop-down menu, you'll see the frequencies for Southern New England. For other offices, wx1gyx.org is a good place for Gray Main information. And if there's questions on other links, we can send around links for the other Weather Service offices. And on Echolink, it would be the NEWENG3 conference. And sorry for skipping the slide here. We're also on IRLP 9123. We generally monitor that. Like anything, it's not necessarily 100% of the time. Over 90% of the time, we are on there to grab data and reports. I mentioned the COCO-RAS program. The Community Collaborative Rain, Hail, and Snow Network is an organization that reports rain, hail, and snow at any time. We do encourage Skywarn spotters that are interested to also join the COCO-RAS program, and you can learn more at cocoras.org. Here's information as far as the Enhanced Hazardous Weather Outlook. That's a graphical representation of weather hazards on a given day, and you see the Skywarn page here at the lower bottom corner. You see local programs, you see the Skywarn program, and then, one of the problems we have is keeping knowledge fresh. About 10 to 20% of people move to different locations, so that's why we require training at least every 5 years to refresh, and it can be either a live or online class. And as we talk about, the quiz is now the method to become a Skywarn spotter at our office. And we've beefed up that quiz quite a bit to allow folks who are not spotters yet to have a path to becoming an official Skywarn spotter. So review time here, we'll go through this quick. This would normally be more interactive in a live class. Under the shelf cloud here, you'll see this is a shelf cloud. So what would we expect? We would expect strong to damaging winds under the shelf. This was in Provincetown, Mass. in 2013. And you'll see here how that cloud features extending horizon to horizon, and then the ominous skull and crossbones flag flying ahead of the Scud. I'm going to try to play this video here, and you can kind of see for yourself what could this be. You see it kind of drifting forward here. Now you see a fire. To me, this could be either Scud or I don't know what's happening. There was a gap in the video, right? So I'm not sure I would consider A, B, or C here. I've always said I don't know what's happening here. Could that fire have been caused from a lightning strike? Could it be Scud? So either D or E are kind of the best explanations here. If you come across this the day after heavy rain fell and you see this, would you call the Weather Service? Absolutely. And also, as a fire chief, former fire chief, mentioned to me, if you can drive up to this, I would also call your local public safety and make sure the road gets blocked off, because if you have a distracted driver or somebody, they could potentially damage their vehicle in this road washout here. This photo is from Cheshire County, New Hampshire, after a flood event. Waking up in the morning and head out and you see this on the trees. Would you call this to the Weather Service? Absolutely. And this is an actual half-inch ice measurement because it's along the edge of the branch to the edge of the ice. So I would definitely call this report in. Cold winter's night and this is happening in your backyard. Would you call the Weather Service? Absolutely. You know, seeing splash over and some minor flooding over the seawall, we definitely want to hear about this activity. Summer vacation on the Cape and you see this, would you call the Weather Service? It looks like a sunny day and not a big deal, but you would definitely call this in because this is 2 water spouts. And one of them actually scraped the shoreline and flipped over the beach shack, and so it was actually also classified as an EF0 tornado. So just an example of water spouts and being able to see it and report it and actually have one of them come on shore as a tornado. Is there anything to report here? No, I can't really see anything here that's reportable. This is just a cloud formation. I mean, maybe it's a shelf cloud, but we don't necessarily report shelf clouds. We just note that under the shelf could be strong and damaging winds, but there's nothing reportable here. This is in Coventry, Connecticut, July 10th, 2013. This is an event here, and you can see a clear upward motion and rotation. Some obstructions in the way here, so I'd say it's at least a funnel cloud right now. And I definitely call that in, and I keep watching it. It's safe to watch it from this person's standpoint. I'd continue to watch it here. I still see it mostly as a funnel cloud. Hard to know that it's touched down. You know, as we get closer here and there's a little less blockage of trees in the way, I might say it's on the ground right about this point. And then you see the debris, and that clearly means it's on the ground. And you could say I have a tornado on the ground. Mention how far this is from your location in Coventry and say I saw debris go up in the air. That's how I know it is touched down to the ground, even though I'm at a distance. Driving in the city and you see this. This is in Fall River. Would you call the Weather Service? Absolutely. And first of all, I would not drive into it either. Definitely some drainage issues in the city of Fall River, but this was after the remnants of Tropical Storm Lee dumped about 5.5 inches of rain in 90 minutes, and this is the kind of flooding you can get from that. So this is definitely reportable. It's a blustery spring day and you come upon this. Would you call the Weather Service? Absolutely. These are, I think I would call this the minimal criteria of tree branch damage to call in. It is mostly healthy trees here, maybe a little bit of rot in this tree, but we're not, tree doctors. I would definitely call this in. It's about 4 to 5 inch diameters down, blocking this road here. And in conclusion, and I'll let the audio play out here.
Somebody needs to call and say, yeah, there actually is one on the ground. It does look like it's coming right at us. I mean, are we supposed to go to the basement or should we actually try to vacate? Yeah, I get it. Yeah, I think so too. I don't think it's that big, huh? It looks like it's going to hit the house.
Yeah, so I would definitely report the tornado on the ground. I would definitely take cover because it's headed right for their house. And then if it's safe to do so afterwards, report what kind of damage it did after it passed your house. So a little bit of humor at the end about what to do in that tornado situation. Again, that was from June 1st, 2011, the Springfield, Munson, Mass tornado. So we've concluded the presentation, and you will see here, if you would like to take the quiz to register as a spotter for our office, visit weather.gov/Boston/Skywarn, and under resources, choose Skywarn Virtual Training Online Quiz. And that will allow you to be registered. If you pass the quiz, you will become a spotter. And so I believe a spotter ID card will get sent to you. If you're not from our office, let us know, and you can email me after the training, and we'll get you set up with their office on how they do their specific training. So that concludes the formal presentation, and only about 9 minutes over time here. So I will now send it over to Jim, our producer, and we can go through any questions here before we wrap up today's training session.
Sure. So we got a whole bunch of questions here we've answered during the presentation, so we'll just kind of hit the highlights and buzz through these pretty quickly. Question came in about how to take the test at the end, and as you could see still on the screen, weather.gov/Boston/Skywarn, you can see the instructions on how to access that quiz there. Can the quiz be used for the 5-year refresh, which was just put into the chat? Yes, you can certainly use that. So everybody that's looking to update their spotter number should visit that. We had a question come in, Rob, and about the NEDECN Digital Skywarn Talk Group, asking us to mention that, which we'll do here. Also, we mentioned as an FYI that not all weather offices in the Northeast have DMR capabilities. Some do. There are others that bring it in as needed. It's definitely another great tool in the toolbox. I don't know if you have anything to add on that one, Rob.
Yeah, so I know DMR has come up a number of times, and we're actually coming up with some linking technology with Brandmeister, which will allow DMR to be brought in over Echolink and IRLP. And the reason I mention that is it's important because not everybody has DMR, but we want to include it. Now, that does not help with any DECN, but that's something that we're looking at potentially updating our New England reflector to eventually handle or bring in a connection that can enable that for us. And it would also bring in D-Star, Fusion, and some other methods. That's number one. Number two, I do want to try to leverage that mode more often. I have been, as I've mentioned before, we usually operate from weather service offices, and we haven't been because of COVID. So one of the things I've been doing personally is upgrading my home station capabilities. I actually started with HF. It's been an Achilles heel. I've not had HF at my house for a number of years. I now have 2 dipole antennas that are giving me HF capability. I may add 1 more vertical antenna to that cadre. I've also been upgrading my other home antennas here. And one of the other things is to get into DMR. And I have a lot of equipment. I just have not used it very much. And that's kind of my next project, is to get more engaged with that, along with getting more engaged with the WinLink and narrowband emergency messaging system modes, NBEMS modes, and there's some training on these topics as part of this New England Aries Academy. So just some line items and things to hit, and something we're definitely looking to do. I know it's been a long time coming. I've said this, I think, in a few forums across about DMR. Again, not that we don't like the capability, it's just getting set up for it and having the capability with us to use, and we will get there. It's just taking some time, and a lot of this is pivoting from where we were before COVID hit to now, and kind of taking a step-by-step approach. Like I said, I got some HF capability here at the house that I felt was needed in first here. Next will be kind of addressing DMR, NBEMS, WinLink, and getting those modes operational and such. So it's a good question. I wanted to spend a minute on that.
Sure. Next question came from Doug, and I believe we've got that answered. But he's looking for a spotter ID number from doing some training a few months ago, and he's out of the Brookhaven office. So best suggestion there, I think, would be to reach out to them for an update. They may be delayed on processing things due to COVID. But seeing it's from their office, I don't know, Rob, you got anything else to add on that one?
Yeah, and if you'd like to have me copied on that as well, I can see what I can do to help push that through. So I can't guarantee I can do anything. It's not our office, but I can certainly try to help with that. And until that time, feel free to report into nets in your local area and let them know you did take training. You just haven't had the spotter number given to you yet. And if you report through our network, we will get that information out to the Brookhaven office.
Sure. And next question comes from Liam. It's kind of an interesting question. I thought this was kind of a fun one to answer. Can a microburst affect no more than a small group of 2 to 3 trees? And I guess that could be possible. If it's in a park and you've only got a couple of trees there, that would certainly qualify under that condition. But anything to add there, Rob?
Yeah, I mean, it's possible. I mean, one thing, the Weather Service, it's interesting because back in the late 90s, early 2000s, everything was a tornado. Now, later days, now everything is a microburst. So in one sense, it's interesting because the education of people now, not everybody thinks that every wind event we have is a tornado, but now some of the meteorologists are saying, well, not everything is a microburst either. Sometimes it's just generic straight line winds, and sometimes we'll get 2 or 3 trees down at one location and then 2 or 3 trees down 3 or 4 miles away, that's not really a microburst. A microburst would be more of a distinguished path. But if there's only 2 or 3 trees in a given area and there wasn't anything else strong enough for it to knock down, I mean, that's a possibility. But it's interesting because everybody's now very quick. And now there's been cases I can tell you that they've classified, people have thought, oh, it was a microburst and it was actually a tornado. So it's interesting how that's become the newest kind of buzzword for every wind event. And what I can say is there are certainly times we've had microbursts, and that's what they are, but there's also cases where it's just general straight line winds, or it's a bigger just complex of winds, like if you look at this past Wednesday. I mean, you could call it a series of microbursts or macrobursts, or it's just, one just huge complex of storms that produced significant winds. So it's just something to keep in mind. Sometimes what happens is we get fixated on specific terms and labels, and it's not always a specific term or label.
And next question came from Bonnie. In a home with no basement, where is the safest place to shelter? That came up during some of our tornado discussions. So certainly most interior room on the lowest floor of your house is the best bet. Anything to add on that, Rob?
Right, exactly. A closet, a bathroom where it has the bathroom pipes that keeps the room whole. And there's been examples where we've had structures totally destroyed, and what survives are like the bedroom closets or in particular the bathrooms, because of the additional piping and such. Those are the best places to be. And again, on the first floor, a smaller interior room on that lowest floor.
Okay, next question is from Patrick. Good morning, Patrick. Asking for any recommendations on a handheld wind gauge. There's certainly the SkyMate options, the Kestrel options, and a couple others. Anything quick on that, Rob?
Yeah, so I will just state this up front, that this is not a National Weather Service recommendation, because the Weather Service can't recommend one instrument over another. I've had better luck with the Kestrels. I actually got a SkyMate once, and it actually didn't work for me, and I had to return it. Kestrel seems to be the best handheld brand name out there, at least that I know of recently, and that's just my personal recommendation. So just something to keep in mind there. I think the Kestrels have been kind of the best ones to use.
And we had a couple of clarifying questions here on measuring radial ice. And I guess the general question is, do we divide by 0.4 or multiply by 0.4, because the slide had both? Yeah, I know. And I think for next year, we have to address this from a training standpoint. You saw I kind of avoided the multiply by 0.4 thing. I kind of just went with what was on the left-hand side of the slide of how to look at it. If it's an uneven surface, it's to divide by 0.4. If it's from the edge of the surface to the edge of the ice, you just take it for what the exact ruler measurement is. And I think just specifying what you did with that will help with the data collection. And I think, Jim, I think we need to take an action in our next Skywarn meeting to go look at that and clarify it again, because this also came up in May. I think we have to clarify that a little bit better for training purposes. But I think if you just tell us that you measured it from either that first method or second method that I mentioned, then we can deal with the math and handle it accordingly. Certainly, yeah, definitely. Next question from KD1JLW. Is there a place for someone to look up their ID number?
There is not today. It has to go, if you send me an email, we can work with the forecasters to get you that number. And if you need a replacement card, it can be sent to you. This is one of the areas I think we definitely need to work on with the weather services, how we can better manage this these days. There's obviously the concerns around privacy, but these days everybody's data is online, and the data here is not nearly as sensitive as credit card companies and other things, but it is a sensitivity area because it is government, and some have concern of the government's eyes on you and things like that. So that's why a lot of that stuff is not available online. But certainly, and certainly, for example, with our WeatherVault app idea, we will want to collect, some level of name, address, phone number information, just for some of the capabilities of the site. And certainly one could be entering in your spotter number and putting it in there, and then you'd always have a record of it. And that and actually it's actually a thought, even in our ARES databases, I don't think we have a field for the spotter number, and that might be a good thing to add, so that folks, when they redo their training or take the training, they can put that number in there in case they lose their card and such. So I appreciate you asking that question, and just thinking on the fly here, I think we have an action to maybe go take even on our ARES databases to add that field, so you could just put it in there, and that way you don't forget it.
Okay, and again, I know we're running a little bit long on time. I appreciate all these questions. We'll try to get to as many as we can. I'm going to group these next 4 together because they're all fairly similar. Essentially, coming from the Gray Main area, a lot of questions about where they should take training. If you're a spotter in the Gray area, how do I let them know this is a refresh for me? And if we still monitor any New Hampshire repeaters. Yeah,
so I mean, we occasionally will go on a New Hampshire repeater. It's been quite a bit different this year with COVID because, where we aren't at the weather office, a lot of times we're on with just our personal call signs, and, sometimes that's recognized and sometimes it isn't. But we do sometimes go on some of the New Hampshire repeaters, particularly the ones that, are adjacent to our office, because we want to hear what's happening upstream before it gets into our area. I can definitely, we should grab their information, Jim, and I can follow up with the Gray office on how they want to handle the training. And, and it could be as simple as, if they don't have a quiz structure and they want to use that to affirm that people have retained the material, it may just be showing them that, and then it'll get handled by the other offices. So we'll definitely take an action around that. My plan was to actually have those actions taken care of before this training, but between the severe weather episode of Wednesday and also from the hurricane net perspective that we run on Echolink and IRLP, the activation for Hurricane Delta, I just did not get the time to proactively do that. So we will take that action and follow up post-class, and I appreciate everybody's understanding on that.
Sure, that's great. And yeah, if anybody wants to pass on their information, I know one of the spotters just did. You can either drop it in the Q&A or send it in the chat to all panelists, and we'll have that for you. Next question, and I'll lump these 2 together as well. How many times can the test be taken if not passed the first time, and do spotters get credit for this refresher? And obviously, yes, you do get credit for the refresher, but Rob, you want to dive into those?
Yeah,
2?
I know a few that have definitely retaken it more than once. I don't think there's a limit. And if it is, it's probably like over 5. So, but I don't even think there's a limit that I'm aware of.
Sure. And we did get, just for your information, Rob, a couple of people that are saying things such as, thank you for sharing your time and expertise. You make a great team for this type of presentation and class. And it's certainly our pleasure to be here for everybody this morning.
Yeah, definitely. This is the different time, and I haven't done a session like this since May, and and certainly we've kind of had to keep the social distance thing going, and like I still have on a personal level visit certain family, certain friends, but typically Jim and I would be getting together, and it would typically take a couple of amateur radio related trips, and we haven't done that this year. It's nice to kind of do these types of things. I forget how much I miss this type of activity. And, one thing we're going to do in the Eastern Mass section after the New England ARES Academy is done, because we don't want to conflict with this, and I think this is just a great thing we're doing for the division at a New England level, is do some more of these types of trainings on a section level, both for ARES and Skywarn and other things. And it can be a great venue to interact and also get some more training out, and it's easier. People don't have to travel. It makes things a little bit easier for folks to get on more of the trainings. It will never replace live classes, and I long for the day where we can go back to doing things live. Maybe we don't do as many as we did pre-COVID, but we do some of them because it's important to have that person-to-person interaction at times as well. But I think there's also some benefit in doing more things virtually because you can get more people. You eliminate travel time and things like that as well. So but there'll be a balance between those things. So I appreciate everybody giving their feedback and thanking everybody for that. And we're really glad to be here. One last thing I'll mention too is we do have a Skywarn announcement email list that folks can email me about if they want to be on it. A lot of that information is also shared on our social media feeds and on Facebook.com, WX1BOX, Twitter.com, WX1BOX, and that references our website, WX1BOX.org. And I know there are some other Skywarn related lists, particularly for the Gray, Maine, and some of the other offices, and certainly like in New Hampshire, the New Hampshire ARES list pushes Skywarn information to that list at times. So just some other things to keep in mind for information venues as well.
Okay, we good. We'll say we'll do 5 more minutes. Get a couple of questions down in the chat box asking for an email contact, Rob KD1CY at Comcast.net. I think that'll be a good way to reach out to you.
Yeah, that works. I have a Gmail one as well. The Comcast one had died on me for a while, but it's been working fine lately, so we can stick with that one.
Okay, awesome. What we can do, again, we'll go a couple more minutes here. I do see a hand raised. Somebody wants to ask a question. Time permitting, we'll go to 11:30. If you want to raise your hand and ask a question direct, we can certainly do that. Victor has had his hand raised a few times this morning. Why don't you go ahead, unmute yourself, and feel free to ask your question. Okay, I don't see him there. So, what we'll do is feel free to go ahead and raise your hand again if you get a question. A couple more that are coming into the chat, the Q&A box. David, KD4CLJ. Good morning, David. Trying to coordinate with Gray, Maine for New Hampshire. So I don't know if you have any advice for him there. And also, Tim is saying, we've done another excellent job. Impressed with the introduction and summary. Thank you for taking the time. And again, we appreciate you joining us there as well. So again, there is an option in the bottom to raise your hand. If you want to hit that raise hand button, we'll go ahead and have you ask your question live. I'll pause for a moment if anybody would like to do that. Again, that's at the very bottom of the screen if you scroll down. And I see, a couple of people are certainly putting in a question that says there's no button to unmute for participants. That's something we'll handle on our end. Just need you to go ahead and hit that raise hand towards the bottom, similar to where you're accessing the Q&A box. Rob, we got a question that just came in about wind gauge recommendations, saying thank you for those. What about rain gauge suggestions?
So like I said, if you go to CocoRAS website, they have an excellent rain gauge for about $30. That is the what I would recommend. Then from there, yeah, that's a manual one. Certainly anything from, if you're looking to get a more elaborate weather station with wind instrument, temperature, etc., you can look at Davis. WeatherFlow is a new one that's has my interest. It's a bit of a different design from a Davis that is becoming popular. That's another example of a decent weather station. There's some from La Crosse and so forth, but like I said, the CocoRAS gauge is about $30, and that's an excellent gauge that is used. And there are other manual hardware style rain gauges for anywhere from about $10 to $30 that you can look at as well if you need something that's not so pricey.
All right, thanks, Rob. And, go for another minute here in case there's any last thing. I know somebody did just say the iPad has the hand raise at the top of the iPad, which I did not know. So, again, we'll pause anybody else has a question or would like to ask something directly, you can use the raise hand feature. Otherwise, we'll be wrapping this up in about a minute or so. In the meantime, somebody suggested for David either using Gray or Mount Washington to access the Gray Maine Weather Office by radio. I don't know if you got any advice there, Rob.
Yeah, I believe that is one of the repeaters for Skywarn in New Hampshire. Part of the issue is it's hard for Southern Maine to get into some of the repeaters in New Hampshire, even from the weather office. And also, I know they have used the Skywarn Talk Group for some of their operations, as well as the New Eng 3 conference IRLP 9123. It isn't just a Norton office thing. It is also used by Gray, and folks from Gray do come on looking for people at times there as well. So that's some additional feedback across for the areas of New Hampshire and Maine looking for Gray Skywarn.
Okay, and we'll wrap up with the last question that came in. Again, it goes back to the ice accretion slides from earlier, and just somebody noting that dividing by 0.4 makes 1 inch into 2.5 inches, and I think that points us back into an action item we have to take to review that and see how best we can make that clearer for everybody. So we'll wrap up with that, Rob.
Yeah, no, I agree with you guys that's it's a questionable area, and I think that's something we need to address with the forecasters. This was something that we brought up in one of our meetings, and they went and reevaluated it and came up with this criteria, and I think it's actually more confusing to folks. So we will definitely get back to folks and clarify that criteria and let folks know what that is.
Okay, and with that, I believe we've cleared out the Q&A box. I don't see any hands raised. So again, thanks everybody for joining us all this morning. Hope you all have a great rest of your weekend, long weekend, hopefully. And everybody stay safe, stay healthy. And Rob, to you for the last word.
Well, again, thanks to everybody for joining. I know it's a nice day weather-wise to do other things, but you chose to stay in your homes and participate in today's training. And we're proud to be the kickoff of the New England Aries Academy. There are a lot of other great sessions. We hope folks will attend those. There are several websites that have the training schedule out there, so we hope folks attend those sessions. We will be teaching one of the 1-hour sessions towards the end of October on situational awareness and reporting, which is beyond just weather. It's also reporting damage, infrastructure, and other things. So we'll look forward for those that will participate in that 1-hour training as part of the Academy later this month. Again, thanks for everybody to joining. Thanks, Jim, for being the producer for today's program. And we look forward to talking to everyone soon on the air during Skywarn activations or otherwise. And we look forward to working with all of you. Thanks again for your time today.